Geometry. 11.5. Area of sectors and circles. By the end of this lesson, you should be able to find the area of a circle. By the end of this lesson, you should also be able to find the area of a sector. If you remember what we learned from 11.4, then what we're going to learn today is going to seem very similar, and it'll be helpful to look over 11.4 and know what you're doing with 11.4 and finding the arc length of arcs. So, looking at this, we're talking about a sector. And what is a sector? Well, the sector of a circle is going to be the region that is bounded by two radii and their intercepted arc. So here we have two radii, and this would be the intercepted arc. So our sector is going to be this portion here. It's easy to think of a sector as kind of a piece of the entire pie. If we're talking about the circle being a pizza pie or a pie or oatmeal cream pie, just the portion of it would be your slice, and that's your sector. Before we can find the area of a sector, we need to take a look and make sure we understand how to find the area of a circle. And this should be somewhat of a review from middle school. The area of a circle is going to be pi times the square of the radius. So in other words, we usually think of this as area is equal to pi r squared. Let's take a look at a couple examples using this. So the first example asks us to find the area of circle P. We're going to start with area is equal to pi r squared, and then substitute in the measures we know and solve for the ones we don't. We're asked to find the area, so we're also given our radius, and we'll substitute those values in. So area will equal to pi times 14 squared. If you're looking for an exact answer, we would just square 14 and leave pi next to it. In other words, you would just write 196 pi. Since it's centimeters, we would say it's centimeters squared. For an approximate answer, you can multiply pi with 196. That would give us about 615.8 centimeters squared. Depending on the context of the question or based off of what it asks you, either answer is going to be more appropriate. So in this case, it just says find the area. It doesn't really matter which one we chose. The next one's asking us to find the diameter of circle Q. Well, I do have my area formula, which is area is equal to pi r squared, and I do know that there's a relationship between the radius and the diameter of a circle, and I know that the diameter is equal to 2 times the radius. So if we can solve for our radius, then we can substitute that into this equation to solve for the diameter. In this case, we're given the area, so we will say 125 is equal to pi r squared. And then we're going to need to solve for r. So first we'll need to divide both sides by pi to try to isolate our variable. These will cancel. R squared will be equal to 125 divided by pi. And then to isolate r, we will need to square root both sides. So for an approximate answer, we can say that r is equal to the square root of 125 over pi. But this measure doesn't really make too much sense, so let's go ahead and calculate this. And the square root of 125 divided by pi is approximately 6.3 inches, because we were dealing with inches squared previously. Now that's our radius. If we're interested in finding our diameter, we need to multiply this by 2. So we can say our diameter will be approximately 12.6 inches. Now that we are familiar with the area of a circle, we can start taking a look at what it takes to find the area of a sector. Just like our formula that we had for the arc length of a circle, you're going to find the area of a sector formula to be somewhat similar. So the area of our sector is a portion of the entire area of our circle, which we can write as pi r squared. And the sector is defined by the degrees that you have for this angle that's formed by the two radii that cut it off. And so from that, we would say angle, or you can also think of this angle measure as being your intercepted arc. So either or is acceptable. Now the second equation, you can still use it. It's really the same equation as this first one. This one is just solving for A. So if we recopy what we had down over here, that your arc or your angle measure for your central angle over 360, and solve for A, we'd be multiplying by pi r squared. But this setup for the formula is really only helpful if you're finding the area of the sector. But we know that sometimes we're asked to find the radius or the diameter when you're actually given other pieces of this relationship. Let's try a practice problem. This one asks for us to find the area of the sector. So our setup that we had was the area of the sector over the area of the circle is equal to, you can call this your central angle measure over 360 degrees. Remember that your central angle is going to be equal to your intercepted arc. So whatever you choose to put here doesn't really matter. Now we can substitute in the values we know. So we know the area of the sector is what we're trying to find, so we'll put our variable there. The area of our circle is pi r squared, and since 7 is our radius, we'll substitute 7 in for r. The central angle we're given is 110, and this will always be part of the whole, which would be 360 degrees. Once we have our setup, we can simplify, and we have x over 7 squared gives us 49. So the area of the circle is 49 pi units squared over, or equal to 110 over 360. Then we can go ahead and cross multiply in order to solve. And this, I'll do the work here. There's a little bit more room. So we can say 360x is equal to 110 times 49 pi. When we simplify this, we have 360x is equal to whatever 110 times 49 is, which will come out to 5,390 pi. And then to isolate x, divide both sides by 360. These will cancel, and x is equal to this amount. Now, if we want an exact answer, we'll want to just simplify this fraction. So 5,390 divided by 360 ends up being 539 over 36 times pi units squared. For an approximate answer, which is acceptable because they do not specify in this problem, we will multiply pi with 539 over 36. This will give us about 47.04 units squared. That's pretty much it for this section. We'll practice more in class, but it's time for our joke. And our joke today is, what do Winnie the Pooh and Jack the Ripper have in common? They have the same middle name.